The topic that I chose to speak about today is a topic that is kind of a non-traditional way of solving architectural problems. And the reason I chose to speak about the topic is that often in computer science degrees or in engineering degrees, it is not commonplace to actually look at these alternative ways of designing systems. And I thought it would be an interesting alternative way of looking at how systems can be designed. So my name is Ahmed. In this conversation, I'm representing Yoco. I'm not going to speak too much about myself, and happy to have a chat about that privately if necessary. So the topic, as I said, is modern distributed architectures. One of the two topics in there is hopefully an introduction to something called event sourcing and some conversation potentially around a technique we call CQRS, which is Command Query Responsibility Segregation. The quote here is just an indication of the zeal and pursuit of continuous learning. And event sourcing has some correlation with this idea of continuous learning. The fact that data that is originated through what we call eventing can be used in the future in ways that you may not have anticipated. And we'll see how that comes to bear. So to speak about event sourcing, it's actually quite important to actually look at what are the traditional ways of actually architecting systems. And one of the traditional practices that we use when architecting systems is if you had a simple order management system, typically most styles of development speak to trying to find out what are, if you're using an object-oriented style, what are the nouns in the system, what are the verbs? So what does the system record and what does the system do? But we often tend to see that a lot of the design is based on what the data structure is going to look like. So how are we going to store this information and how are we going to retrieve the information later? So a lot of the traditional architectural principles are based on those principles. How am I going to store it? How am I going to retrieve information? That often correlates with kind of this idea of I need to create some data in a database. I need to be able to retrieve that data or read that data. And I want to be able to update that same data and delete that data. Something that is often described as the CRUD-based operations that need to be performed against data. The thing that's interesting about this kind of data-oriented or state-oriented way of the world is that actually it isn't the way we as humans think. If humans met in a coffee shop, so if I met Shay in a coffee shop, it would be seldom that I would ask him a question like, how's it going? Or what's happening? And he would respond with his current state of the world, i.e. his state of mind or his state of being right now. He would not tell me, well, I've got a house, I've got a car, I've got a cat, you know, I've got pain in my right foot. I've got crippling self-doubt because I'm terrible at conversations or something similar. What he would often do is that would be actually quite crazy for him to relate everything that has ever happened to him since the beginning of time and record it as a narrative of all the feelings he has right now or the possessions he owns. In fact, what happens is, because we're friends, is what he would often do is he will tell me all the new things that have transpired since the last time we spoke. So there's a sort of baseline for the next conversation that is predicated on the previous conversations I've had. And what I'm trying to do is catch up to the latest happenings in his life. In short, what he does is he tells me a story, which are a sequence of things that have happened to him since the last time we spoke. And those sequence of things are what we call events or interesting pieces of information. And that's the way we as human beings actually think. We don't think in terms of stored state. One of the other problems with traditional design is that it forces this idea of a single data structure to store information and to use that same structure to be able to give us and answer questions that we would like to have answered based on the information that's stored. So what we call the read model and the write model. How we store information is fundamentally used for both reads and writes. What's worse still about this single concept or the single model of data is that often you actually lose information through the process of storing current state. So an example of that would be is if you built a system that recorded your customers, and if you stored the customer's address together with that customer's data in a database, often what you're storing is the customer's last known address. And it would be impossible to answer questions like, so what has the customer's address been over time? What was his address last year? Or if you were speaking about a customer's name, has the customer's name changed over time? Or do we actually only keep the last known name for the customer? And in fact, because you're storing current state, what you've lost information through the process of storing just what you know right now. So based on that backdrop, how does event sourcing or an event sourced architecture differentiate itself? What event sourcing is instead of storing the current state, so what we know of the world right now, what we store is the narrative about how a particular set of data reached its current state. So we store the interesting facts that led us upon that journey. And because we store the interesting facts, we then have techniques for being able to derive what the current state is. So in essence, you can boil it down to just a different way of storing information. It's a different way we store data. And instead of storing the last known piece of information, we store every piece of information that are the facts that have transpired over time. So here in event sourcing, the focus isn't on what the current state is. It's focused on what are the changes that have been over time. And we'll look at examples of this shortly. So event sourcing as a concept isn't new. It's existed for a pretty long time, both in computer science circles and engineering circles. But in fact, it's existed outside of the technology industry. If you speak to industries like the finance sector or in the accounting environment, often a ledger is actually a form of storing the facts. And when a particular store, for example, stores the transaction history in either some sort of a journal, cash receipts journal, a cash payments journal, those become what we call the source documents that can then be used in order to post into a ledger. And what the ledger is, it's the current state of all those transactions over time. And we can throw away the ledger as long as we have the source documents. So in the accounting arena, it's quite commonplace that you have source documents and you have what we call derived documents, the trial balance and the balance sheet as one example of them. So the accounting industry has used this for a very, very pretty long time. You also have in the healthcare industry or in the insurance industry, this idea of contracts and the way you create a contract or you sign up a contract or you take out a new policy. And any addendums you make, like changing your address or you getting sick and having a new pre-existing condition, or you getting married or you having children, these are all significant events that would change the nature of the cover that you may enjoy as part of your insurance environment. And those are actually recorded as addendums to a pre-existing contract that you may have already signed, indicating the additive nature that what you're doing is making an addendum and you continue to make addendums. And the collection of the contract plus all its addendums reflect what the current state is. So this technique has been used in various industries. In healthcare, for example, every time you visit a doctor, he basically logs a new visit and he adds that new visit to your file. So these are typical of industries that do this. So what does it all mean and why does this even have any value? So one of the things that event sourcing architectures can give you if you are able to implement it is that it can provide this kind of reliable audit trail, a reliable track of every state change that has ever taken place over time. But more importantly, those state changes are a first-class concept. So it's baked into the way you work, because like in the accounting profession, what you're recording is the information or the facts that have occurred as source documentation. So it's not an afterthought, but rather it's decided up front, reducing the inherent risk that is typically there in trying to record state changes in an audit trail, which is an after the fact measurement. If you do it this way, you then have a stronger guarantee that information is not lost because you're recording things as they happened. And as a result, you can potentially use old information in the future to derive new interpretations of that data. In environments where compliance is key, so environments where there's a risk of security breaches, in environments like healthcare where there's privacy breaches that are important to ensure that one does not violate, in the financial services industry to make sure that money doesn't leak through whatever particular system because of fraud that is either internal or external. Or you can imagine a voting system that would give you a reliable audit trail of every vote that took place so that one could reliably tally up those votes and ensure that there was no repudiation of that data. So having an ability to record the facts helps you to achieve some sort of regulatory compliance, and again, becomes a first-class principle. It actually reflects the real world as I described earlier, because the real world is actually one where human beings communicate based on a narrative of things that have happened. And it is seldom that when we speak as human beings, we speak about how we want to store that information. Our brains are tuned to sense info through the 5 senses that we have. And it's through those senses that our brain figures out a way to compartmentalize those facts. But our brain also has ways to derive new information from those facts. So it is much more in tune with the way the human brain works. The other thing that's interesting is because we as humans don't think like that, our domain experts actually don't think like that either. So the domain experts who are experts in healthcare or finance or remote learning or banking, these are all domains where often when you ask a particular individual in that domain about how they conduct their business, they often explain how they conduct their business in terms of the things that they do or the processes that they embark upon or the activities that they perform, like taking a payment, like swiping a card in the payments domain, or adding a visit to a patient file in the healthcare doctor domain, or opening up a bank account in the banking domain. It's all around activities. And given that it's all about activities, it is more comfortable to explain those concepts in expressive models that are all about events and processes rather than just thinking about state. So it enables better communication as a result. Another side effect and benefit of this is that it also allows for a much more simpler way of sharing and storing information because it's just a set of facts. You can imagine it as a long ticker tape. Think of a cash receipts journal that you may have done at school level accounting, where all you're literally doing is recording every sale that took place. I mean, that's a pretty simple thing. Here's the date, here's the time, here's the description of the sale, this is the amount I sold for. And it doesn't have an inherently complex structure. And as a result, you can design storage system for these facts that are really optimal for that kind of design. So how does it all work? In the banking domain, as an example, we have a concept called a bank account. The bank account principle is, it's an interesting question. It's about asking, how do you think a balance is stored in your bank account? So how is a balance modeled in your typical bank account? And often the case is that most people would say, well, it's probably going to be something to this effect, where I'm going to have some sort of an accounts table in my database somewhere. It's going to have probably 2 columns in it, something that represents the account number. Maybe it's a key, a primary key of some sort, and some sort of a balance field. And that could be quite a naive way of modeling an account, but it is one potential way of modeling accounts and storing the balance over time. The challenges with a typical model like that would be, so what if you disagree with your bank? So often, this is not what the bank does. What they actually do is they want to be able to tell what the movements of money was in your account over time. So they typically model that as some sort of a transactions table where they would allocate the movements of the money in and the money out of that account. So a deposit or a withdrawal from that account would be logged as each independent transactions, fairly similar to the idea of just logging the events as they take place. In this particular example, if you ask the question, so if you ask the question about how would you derive a balance from a table that looks like this, which shows movements, often what we do is we say that the balance is actually just a simple mathematical equation, where what the balance is, it's a simple sum of all the transaction amounts within a particular date period, and that will give you the running balance of the account. So what you have there is the idea that if you store the transactions, what you have is the ability to derive what the balance is without necessarily storing the balance. And a primitive example of how the facts of the movements on the account can lead to derived information, which is, in this case, the balance of the account. So stating it differently, what we're saying is that here the transaction is the facts that have already happened that we record, and that the balance is the current state of the account. It's the transient state, something that can be recalculated at any time, something that you don't need to store to be able to gather what the balance is at any particular point in time, because you have source information, the actual facts, events, or transaction history to be able to derive that knowledge. So event sourcing is actually based on this principle. And we'll look at a kind of another example of that a little later on. So in the accounts example, what you're doing is you're basically modeling the movement of the account as a sequence of events. And they describe basically an event is something of interest, a fact that has occurred in the past of interest to you that you want to record, something that cannot change, something that is immutable once it's been created. So if you had to look at it in terms of an event of facts, there would potentially have been a fact that says some account was created at some point in time. That's an event that has taken place, followed by another event, which would be something like depositing of money into an account, in this case, a deposit into account 1 of 20 Rand, followed by another deposit of, I think it's 10 Rand, sorry, a withdrawal of 10 Rand from that same account, and followed by another withdrawal, sorry, another deposit. So these are the facts that have occurred to this particular account. Given these facts that have occurred, what are we able to do if we are able to store these facts? In theory, we should be able to derive what the balance is. So they're always expressed in the past tense because an event or a fact is something that has already occurred and cannot change. This allows us to make sure that the events become what we consider the only source of truth. So as an example about how you then derive state from those facts, what you see here is an example of that first event. What you see is an event being applied to a hollow empty object, an account, or a hollow empty concept here, an account. And when you apply that event against that particular empty object, what happens is that object derives the values that are inherent within that event. So in this particular case, the account basically gets opened and it gets an account number of 1 with a starting balance of 0. If you then had to start at that point where you already have an account with a starting point of 0, and you deposit money against it, and you apply that new event, which is a new fact that has already transpired against that account with no money in it, what you would expect is that it would then increase the balance of that account by 20 Rand, which is what you're seeing now. And if you replay that ad infinitum, ad nauseum, taking the next event, which is the withdrawn event, apply it on it, and then take the next deposit event and apply it on it, what you have is the ability to get the account object or the account entity or the account concept to now reflect the current state, which in this case here means, in this case here shows now that you have 50 Rand in the account. So, which is the derived balance based on going through all of those application of those past facts. So what this reflects is that current state can always be derived from all the past events that have transpired. What event sourcing tries to do is to make sure that you put these facts or these events at the center of your domain. So when you're doing your analysis, you're not focusing on how you're going to store the data, but you're rather focusing on the important pieces of information that you want to record so that you can later reflect upon that information to derive new information. So often the case that the question that comes up is so in traditional architectures, we are able to build what we call audit trails or mechanisms to do logging of events. And of course, there are techniques that one could use with traditional architecture to do that. But many of them tend to be after the fact. In other words, we design the state of the system up front, and then we try to impose some restrictions on that data to try and model out changes. So we try to record what has transpired over time. It is definitely possible, but it does make things more complicated. Some of those techniques are being able to then parse a set of log files to try and determine what has changed, or creating what we call hierarchical or historical tables or temporal tables in order to reflect the state changes of a particular database over time. So in the example I gave you earlier of a customer changing his address, what you would have is not just store his current address, but you would have some sort of a one-to-many relationship to an addresses table, and you would store all his addresses over time, and perhaps keep a date and time to indicate which one of those addresses is the active one at this point in time, complicating your structure. And what if I decide later that I not only want to show the addresses over time, but also show name changes over time? Then you need another table to reflect the customer table to a names table, which shows name changes over time, hence complicating the architectural design. So eventing and audit trails are not baked into the way we design traditional systems. There's also kind of a impedance mismatch between what we consider logging and what we consider sourcing. So sourcing is having a single source of truth and using that single source of truth to which contains the facts that which have transpired, and be able to use that information in order to be able to derive new sources of information. So the word sourcing is quite critical because it forms that single source of truth. Whereas event logging is completely different. Event logging is you store data in some sort of a data structure, and then you parse data out of that data structure in order to try and create some sort of an audit trail or some sort of log infrastructure. The one is not a single source of truth. They are alternative sources of information that may need to be combined to get a full picture. So I see there's a question about, is CQRS like CRUD and how does it compare? I will answer that question hopefully a little bit later on when we get to the CQRS section. And if not, welcome to please ask the question again. So in event sourcing, the event is a first-class concept. Everything is sourced from that past history. Another example is a shopping cart, and I'm going to go a little bit faster through this so that we can make use of the time effectively. So a shopping cart is another example in the e-commerce industry. The examples I've given you are kind of examples that are fairly commonplace within the Yoco ecosystem. So we have a e-commerce solution, and shopping carts are quite important to most e-commerce solutions. So when you buy using a shopping cart, often we again, because of what we've been taught, think about how we want to store current state. So we're going to have a shopping cart, and that shopping cart needs to have many line items in it representing the items I've added into the shopping cart that I want to purchase, and potentially have an associated set of address information and maybe payment information associated with that cart. And that would be what a traditional design would look like. So we've been taught that what we focus on is the shape of the data. We focus on the shape of the data as opposed to what we're trying to do. But we can also express the exact same shopping cart as a sequence of events, as opposed to worrying about reflecting current state, allowing us to focus on business process. So what would that look like? So with a shopping cart, you could boil it down to a couple of key events. The fact that a cart gets created when you open up a web page like Take-A-Lot and decide to start your shopping. every time you add an item into your cart, a new fact is recorded. The fact that you added an item to your cart, item added, followed by another item added. And lastly, you would have your, for example, providing your shipping address to indicate where you want to ship it to. So with event sourcing, what you're doing is just recording these facts in kind of like this never-ending stream of facts, hence referring to it as append only. The data is immutable because once it's happened, it's happened. Immutable meaning not changing. It cannot mutate. So these events never change over time. A key question that often comes up, so now what? What happens if a mistake took place? How am I going to fix that? So what we have is a technique called compensating events. And you probably would be used to this if you've done some, again, accounting at school. In the accounting world, there's this principle in accounting that money can neither be created nor destroyed. And what you have to do in order to reflect a change is not use TIPEX, but rather to indicate that through a compensating transaction. So if you credited an account with the wrong amount, you need to debit that account to reverse the effect of that erroneous credit and then credit it appropriately. Again, reflecting that the nature of information is never lost. So at any point in time, an auditor can look at that and say, I can see a mistake was made here and here it was reversed and now everything is okay again. So we can apply compensating events in the same way, which then does not ruin the historical nature of what has taken place. So what does the shopping cart look like with compensating events? We looked at one without compensating events. You would have a cart created, followed by an item added, another item added, and you choose to then remove the item from the cart. So you would indicate that through another fact. Sorry, I added that item erroneously. I would like to now remove that item. That is a fact that is worth recording, and it's information that is worth not losing because there's some interesting pieces of information you can derive from that. So the question is if you look at the two models at the top and at the bottom, and asking the question about, are they actually the same thing? The answer to that question is they actually nowhere near the same thing. The first one records the fact that an item was added and removed, and the latter one potentially does not when storing it as state. So you've lost knowledge. It doesn't matter what model you used to store the data in an event-sourced architecture or whether you use the traditional architecture, we can land up with the same state. i.e., after you've gone through those facts, you can still end up with a cart consisting of those exact line items that need to be shipped, not the ones that were potentially removed through the process. So you can still choose to see the state as what it is as of now, as opposed to what it is over time. So you have the ability to almost not lose information, but still view it through a lens that is what you want to see. Here's the current items. The key thing, though, is that in a shopping cart, for example, it opens up some other huge possibilities. And we'll talk about that briefly just now. So this is an example of event sourcing being done in the insurance domain. So I've been fortunate to be part of some interesting projects in my life, and a big insurer in South Africa and in multiple other places in the world uses a large insurance model system heavily based on the event sourcing principles. So the traditional solutions loses data by design. So in other words, you're designing a data structure that inherently is a lossy based system. So it loses data like an algorithm that can compress information, but it loses pixels. An image can lose pixels and the quality degrades. So a relational, typical traditional architecture by design, it's meant to be a lossy based or information that loses fidelity over time. And you cannot then figure out how you got to that particular state. So the example I was referring to earlier is the question you should be asking is how much of data do you really want to lose? And in traditional architectures, that's typically the question you should be asking yourself. So do you want to lose the fact that an item was removed from the cart? Do you want to lose the fact that a customer potentially changed their address because they just typed it in incorrectly? Or you want to lose the fact that a customer changed their address because they've just moved, or they've changed their name because they typed it incorrectly, or they've changed their name because they've got married. These are pieces of information that ideally you should never lose. And the reason for that is that when you lose data, you don't know if that data would have been valuable in some future context. So those events represent fundamental, important, interesting things that have happened. And in theory, they should remain of interest to the business because you can't predict the future. And because you can't predict the future, it will be useful to be able to retain all that knowledge until some future time where we can reflect upon it. So this is truly the benefit of event sourcing, this kind of ability to reflect true intent, true facts. You can then draw deep insights. An example of this would be is if you were able to determine when shopping cart items were removed, you could start doing intelligent things like figuring out how often do people remove items from their shopping cart because they get to the checkout page and realize the amount that they were planning to spend versus the amount that they are spending based on all the items in their cart is more than they have money for right now. And they're removing the items to get to a more a point where they feel it's more affordable. So one of the ways that Amazon, for example, does this is if you remove items from your cart, they will often reach out via promotions to try and offer you a discounted price for that product. But somebody else who had never removed that item from the cart would not be offered that promotion, allowing you to basically convert customers that potentially were ready to buy, but for some reason or the other may chose to not have buy because maybe the shipping costs were too high or the overall cart price ended up being higher. So you are now able to build more deeper insights. It allows you to start doing things like determining what are the top selling items, what are the items that are removed often, and what are the items that are selling effectively. It can allow you to do things like offering items and promotion codes based on mixes of items in the carts. So what items work well together and offering opportunities for cross-selling. So being able to see the insights, being able to derive insights from the facts, because you have them, allow you to draw new information in future. The other benefit we spoke about earlier is the regulatory compliance. So you can actively track what was changed, by who it was changed, when it was changed, where it was changed, why it was changed, giving you a true ability to create audit trails. And audit trails are key in achieving regulatory compliance. So audit trails, immutable, meaning that it cannot change. Blockchain is interesting here and how that could apply. You also get this benefit of what we call a time machine. The time machines, like a DeLorean, would allow you to go back in history. And because you can go back in history, you can recreate state as it was at any time in the past. So you can look at, so what was the policy look like in 2018 for this particular patient or insured party? What did the bank account look like at the end of the financial year? Not just what it looks like now, but what it looked like at the end of that financial year, because you want to start figuring out what your tax liability looks like. So you are able to travel in time and be able to derive new insights based on the information that was known at that time. This is it's quite interesting because you can do what we call what if analysis. So people like Shay, who are heavily involved in partnerships and growth, would be able to do interesting things, like being able to figure out what if we did this, what would that impact have, which is quite insightful. So this is a lot about how do you scale this stuff. And I'm not going to go into the details here, but there are techniques for making sure the stuff scales. But if you followed earlier what I said about how eventing uses a storage system that is pretty primitive and basic, it means that because it's only got one job of storing data and kind of like this never-ending ticker tape, it can be optimized for those use cases. So as a result of all of that, it becomes much more simpler to design these systems. There is no mapping, there's no updates, there's no database complexity in figuring out how to store those events. You could use something like Amazon S3, a blob store, and just store data in there. You could use something like an Amazon DynamoDB or a Postgres database or a MongoDB database or a Redis database or a hash map in memory. So there are so many different ways of, if you can model it as a key value pair, then potentially you can store it. So jumping from event sourcing, this is a section I'm going to probably do a much more rapid fire through. So CQRS stands for Command Query Responsibility Segregation, and we'll break that term up a little bit. So basically, Bertrand Meyer created or defined this term. And basically what it's saying is that if you have a particular method or a function or a procedure call in any programming language, if you are querying that particular method for information, it would be better if you don't allow for a side effect to occur while querying for information, i.e., while asking a question, make sure that the answer does not change depending on the fact that you asked a question. So there should be a side effect of it. As a result of querying, make sure no updates are taking place to the database in turn, because that would be something that would be hard to track and it would be hard to understand. So separate out question asking from the actions that I want to perform. Separating out these actions from the questions are often then viewed as what we call reads and writes. So reads are the questions I want to ask, the queries that I want to fire. Writes are the commands or the actions I want to perform. So example of that would be, I want to deposit money into the account is an action I perform. A query I would perform is tell me my current balance. What is my balance right now? Or show me my movements over the last month. These are separating them out allows for some great opportunities. So why should you care about that? Generally, in most architectures, the reads vastly outnumber the writes. Think about something like Facebook or Twitter. The writer of a tweet is a single participant, but the people who read that tweet are volumes bigger than that, right? In Twitter's case, it's an exaggerated even number of reads to writes. In traditional systems, what you'll find is that the ratio tends to be between kind of 5 and 10. For every write, you're probably reading that data 10 times. So if you think about looking at your internet banking account and looking at your transaction history, you more often are querying transaction history than you are getting money deposited and withdrawn from your account. So the writes occur less frequently than the reads. And this is across systems, and it is fairly seldom. There are more exceptions where the writes exceed the reads. That means that we can then optimize. If we separate the reads and the writes, and we know that they occur in different frequencies, we can now optimize and scale them independently and make sure that the reads end up being really, really fast, because we can then scale them what we call horizontally, making sure that we can service many, many clients accessing the same data. And what we do is we make them what we call eventually consistent, not a topic I would really want to go into. The writes are usually much, much faster. And what we try to do is use what we described earlier, an event store, where what we do is we just store the facts. And because it's append only, it doesn't rely on a past fact to store a new fact. And as a result, all it's doing is hey, please store this information now. Please store this next piece of information now. So we can now optimize our data structures. We can optimize the read side to be optimized for this fast accessing queries. And we can use the right tool for the job on the read side. We might not need complex object relational mapping tools like Hibernate and JPA and Slick in the Scala world and active record patterns in the Python world, or whatever other frameworks or technologies you're using. We can also use an optimized store for the right side of the architecture, as I described earlier. So segregating these reads and writes also can result in more maintainable code. What it can do is that because you separated the reads and the writes, you don't have to have specialists that understand both reading and writing. You can probably split the complexity across your teams based on that. This is one description about why you can use this model. So you can have one team just focusing on optimizing writes and another team focusing on optimizing the read side. One side effect of all of this is that event sourcing and CQRS is not a silver bullet. So you need to be careful because it comes with some inherent risks and it's not suitable to all architectures. So although the real world is eventually consistent, eventual consistency is something that needs to be understood. So what does that mean? The real world is eventually consistent. When you deposit money into your bank account, and if you had to, in the immediate time frame that you deposited money into the bank account, go and pull up a bank statement, it does not necessarily reflect that money that was deposited immediately. There's a trickle of when that information will be reflecting in the bank statement. If you had to withdraw money from an ATM, and this is in fact true, if you had to go between ATMs from one ATM to the other, if you really do it quickly enough, you can actually withdraw more than your bank limit because they don't update the final ledger in real time. They update the final ledger in what we call eventual consistent time. Basically, there's a process that is delayed in updating the final truth, the final source of information. So actually the real world is fairly eventually consistent. There's complexity inherent here because it's not the way we designed systems in the past. So curriculum at university and at school are tailored towards the way we traditionally design systems. I would argue that this is actually simpler, but the problem is that you have to unlearn some of the stuff that you did before. It's not mainstream, so it's not as widely used, but you'll find that over the last 5 years, it's become more and more widely used. And in fact, all of the big players, Facebook, Twitter, Google, Amazon, all employ some form of event sourcing or separating of reads and writes. I'm not going to speak about that. So this is a question about how does this relate to CRUD that there was a question that was asked earlier. So in a traditional architecture, what you have is some sort of persona or actor trying to interact with some sort of a web service layer and asking it to open up an account, for example, or to be able to deposit some money in the account and to be able to retrieve the current balance. So this would be seen as a REST API with get and post semantics. And I'm not going to get into too much of details there, but fundamentally an API that allows you to be able to deposit money and an API that allows you to figure out what the current balance is. A traditional architecture looks something similar to this. You got some sort of a presentation layer, you got some sort of a business logic layer, and you have what is some sort of like a persistent storage data layer. And that's typically what a standard traditional architecture would look like. In that particular architecture, the reads and the writes typically share the same database. So what you see in that picture is that the same database on the right-hand side in the bottom right corner is what's used to store information and what's used to retrieve information about the current balance or the movements on an account. In an event-sourced architecture, what we're doing is we're separating out the things we do or the intentions or the actions we perform from the questions we ask. So that's command query separation or segregation. So the commands are the things we do. The queries are the questions we ask to find out about the data or the movements on an account. What you find here simplistically is basically what we're doing is we're separating the architecture into two halves. We have a half that represents the actions, which are the commands, and we have another half of the architecture that represents the queries. What you find that's different though is on the extreme right-hand side in the data layer, you'll find two separate data structures. The data structure on the top right are the events and the facts we store in the database. And the data structure in the bottom right is the events flowing out of that event store into a structured database that is suitable for query, a database that is optimized for reads. So what you're seeing there is a separate read model and a separate write model. Because these reads and writes are separated, you get the benefit of working in isolation. They have their own data store, helps you to move towards some sort of an idea around microservices in future, and allows you to use the right technology. Simplistically, this is what it looks like. You got a client issues an instruction like, please deposit some money into an account. An event gets fired, which is a fact recording something that has taken place, something like money deposited. That money deposited event or fact gets stored in something like an event store, like a continuous ticker tape of facts. When that fact occurs, a thing called a projector, something that projects information, hears that event. And what it does is it tries to record that information in a data structure suitable for querying, optimized for querying. So it will hear that information and store it in a data structure that reflects maybe, for example, the current balance of an account. So it may hear 10 Rand deposited, 20 Rand deposited, 5 Rand withdrawn. Okay, that means that I have in the account now 10 plus 20, 30 minus 5. I've got 25 in the account, and that's what it would store on the read model. So when you want to ask the question, what is my current account balance? It's a quick query to that database engine without needing to do any complex joins or any complex calculations because the data is already preemptively determined. The query side is basically the questions you ask. That query side interrogates that data structure that you've created, which is the read model. The piece at the bottom speaks about how we react to other things and tell other systems to do things. Like, for example, sending an email when when money is withdrawn from your account or somebody debits your account appropriately. So this allows us to separate the read model from the projections. It also allows us to use the right database choices. So now we're not stuck with a single database choice. We can use relational databases when they make sense, document databases like Mongo and DynamoDB or Redis when it makes sense, graph databases like Neo4j or some of the other open source ones, or key value pair databases, or alternatively wide column stores, things like Cassandra as an example. You can do event sourcing without CQRS, and you can also do CQRS without event sourcing. They just tend to really work well together. So they kind of like the yin and yang. That's me. I'm gonna hand it over to see if there's any questions. So is CQRS like CRUD and how does it compare? Was the first question that was asked. I feel like I've answered that question. So CRUD is the way we design traditional architectures, whereas CQRS is an alternative way of designing systems where we separate out the way we read data from the way we write data. The next question was, are there any resources available to learn about building event-sourced applications? Much tougher question. Because it's a newer technique, it is often not, there aren't as many formal and informal publications around the concept. There are a few books over the last 2 to 3 years that have been written, and there are blogs written about this concept, and there are a couple of frameworks that are built around CQRS and event sourcing. If you reach out to me post this, I will point you in the direction of some of that material. Last question. It sounds like event sourcing allows business. So so that was the question there, which we just answered. It sounds like event sourcing allows business to gain insight in behavior that consumers don't necessarily want them to have. Case, Andrew poll target pregnancy. When and where should programs stop the collection of data on clients? So maybe you want to ask that question maybe verbally. I'm not sure if I follow. Ronaldo?
Hi, everyone. You can unmute yourself and ask questions if you like. Not sure if Ronaldo's here, but yeah.
Okay. I'll try and answer the question based on what I interpret from that. So event sourcing as a technique is basically saying, I can't know the questions you're going to ask me. And because I can't know the questions you're going to ask me, I'm not going to try to pretend like I can predict the future. So what I'm going to do is store everything I know about everything that's happened and be able to derive new information from that in the future. So if the question is, how do I gain insight that consumers don't know they need right now? Then that's exactly the case. If you were doing things like trying to determine the correlation between a particular health condition and how eating habits affects that health condition as an example, what you would do is you would record facts. You would record the fact that somebody records every day the items they're eating and records their symptoms that they're feeling. And you might in future be able to use that to populate some sort of a machine learning algorithm, something like a Bayes classifier, that be able to take that information and use that information to correlate across symptoms and the food that they're eating to draw deeper insights as to the likelihood or the prevalence of a particular item they're eating to result in adverse symptoms occurring. You may not have thought about that up front, but you may be able to derive that. So I'm still the CTO, I'm one of the heads of engineering at Yoco. Yoco is an organization that encourages entrepreneurship. Prior to my arrival at Yoco, I was already a founder and a CTO of a company that still exists, that's building contact center technologies. And that solution is built on event sourcing. And we use machine learning algorithms in our contact center solution to optimize which agent we send an incoming call to based on the performance of that agent on past calls that have been similar. We use machine learning to derive that new knowledge from the facts that have occurred in the past. So that's an example of something maybe close to the question that was asked, but I'm not sure. And I'm going to keep quiet now to try and let you have an open session to ask any more questions. I'm not sure how much time we got left in Kosinati.
Cool. I think we have like 4 minutes just for questions. Sabelo is going to start at 2 p.m. So if you have any questions, guys, you can also unmute yourself at this point. Also, please, I'm going to post a link in the chat. I'm not sure if I can still post it. Let me see that. Yeah, so you can use this link to give feedback on the event or on the webinar today. So please give us feedback. We want to know how you find the event.
So just as a kind of punt, anybody interested in kind of learning more about this, you're welcome to contact me directly or to come through Shay. Yoco always looking out for great engineers. And if you reach out to us, go to our careers page, reach out on that email address if there's something there that doesn't interest you or you just want to have a chat. We're happy to continue those conversations in those forums. Thank you very much, Nkosinati. Thanks, Jenna. Thank you, Shay, and thank you, everybody else.
Well, thank you very much, Ahmed, for coming today, and Shay. Thank you very much for joining us today for the presentation. Yeah, I think we can wait a few minutes for Sabelo to get started.
Cool. Okay, Nkosinati, myself and Ahmed will drop off now, if that's okay.
Okay, thank you. Have a great afternoon.
Okay.
Cheers, guys. Keep well. Bye-bye.
Thank you very much. Cheers, bye.
Hello, everyone. I hope everyone is fine and having a good Wednesday. So I don't know if I should start at 2 or just jump into it right now. Yeah, so I'll just share my screen. Okay, my name is Sabelo Mtetwa. I'm the tech mentor at the GDSC UCT for this year and next year. So I'll be going over the Git and GitHub basics using a project I was working on. So I was thinking of doing a project from scratch, but I thought that was going to take a while. So I already have a project, but I'll use that while going over Git and GitHub. I'll just share my screen right now. Okay. Cool. So, okay, I'll just show you the final product of what I'll be doing. If you're interested, you can, if you're interested, you can go and check it out on GitHub or just view it on your devices. I'll just post the link on the chat right now. Cool. Right. Okay, sure. So GitHub is like a system. It's a system that records your changes. Changes in your project, so it records them and then gives them a version. Yeah, it saves them as different versions over time, and then you can go back and check your previous work using an ID and stuff like that, which I'll show you while I go over the project. Cool. So yeah, Git allows you to specify the changes and go back to the work you've done previously if you wanna do some changes and maybe implement a different feature. It also allows developers in a team to collaborate and share their work easily. That can be done through GitHub online repo, remote repos, You can use that to add your stuff, different developers adding their work and then putting them together on GitHub online, which makes everything easier. Cool. So so what I'll do now is start creating the project. Cool. Let's do this. Right. I'll use the terminal. And if you don't have Git already, I advise you go and install it. There are resources online which you can use to install Git, and you can use it on Windows, Linux, or Mac. I'm using the Linux version. I'm using the Windows version of Linux, so it's the same commands. What I'll do now is that I'm under my working directory. I'll be doing the landing page. I already have some resources, which are the images that you saw on that page. Yeah. What I'll do now is create a repo. A repo is like a container for putting all your files, all your project files, which Git will be tracking. So how to create that? You use a command called git init. You do this under your working folder, which is landing page. This is where I'm at right now. And then this just initialized an empty Git repo, and you'll notice that this changed to master, which is the name of the main branch, right? And another thing you should have noticed is that this thing changed. It just went yellow, and there's a U which stands for untracked files, meaning Git hasn't saved the files in its system. And how you need to add them, you just use the command git add, and then the name of the file. If you want to add them individually, you can write the name of the file. Okay, for example, right now I'll just add this growth .jpg image, which is under assets. This growth. So what happened here is that we've added the file into the staging area. It's now being tracked. It's only this file, and you notice that the other ones are still untracked. How to track all the files? You can use this command git add and the full stop, which is going to add all of them into the staging area. Right. And yeah, from there you can check which files are in your untracked area or the staging area or committed files by using the command called git status. Cool. So this shows that I don't have any untracked files. What I have is these files which are ready to be committed. They are tracked, they are staged. Let's say you don't like any an individual file from these, and you want to unstage them. I think there's a command here which was written. Yeah. So what you do is use this command to unstage a specific file. Let's say I want to unstage the growth file again. I can use git remove a cached file, and then the name of the file, which is under assets and growth.jpg. This is going to unstage the file, and you notice that it changed from A to U. Yeah, this command only works for one file. If you want to unstage all the files in your under your repo, you can use this command instead. Remove catch, and then the flag R, meaning you do that recursively. Oh, sorry. Okay, wait. I think there's an error. Wait. Okay, bear with me, guys. Just want to check something out. Oh, also, I'm going to share a file, some notes that I made for Git. I'll just share them on the chats. Some notes if you want to check them while you're working on your projects or your hackathon projects. If you're taking part this weekend, yeah. So I'll just save this to the chats. Okay. Okay. Yeah, I just sent the link or the doc link on the chats. You can check that if you wanna see the Git commands. Those are the basic notes that I made. So yeah. So after this, I wanna check something. So you use this instead to unstage all of the files. Sorry. Cool. So cached. Okay, I don't know why it's not working. And the name of the file.
There is a full stop at the end of your R.
Okay, thank you, Tepi. Yeah, I missed the full stop. Meaning, you're recursively unstaging all of the files. Yeah, thank you for that. Cool. So now what I want to do now is add the files that I'll be working on. So this is an HTML and CSS static file. I'll just add 2 files, or I'll just use the command. I want to add the index.html file and the CSS file. And I also want to add everything to the staging area of Git using this command, git add everything. And then after this, your files are ready to be committed. So I'll just commit all of the files using the command git commit and the M flag, which means that you have to put a description message describing what changes you've made. So I'll just give it a basic description saying edit some files. Yeah. So here on the description, you have to put something that's that will make sense when you go back in time and look at your changes. Yeah. If you put anything that doesn't make sense, you might look back and not know what to do next. So from here, all my files are saved on Git. Now they're ready to be pushed to GitHub if you're ready to push to GitHub. So I'm just gonna sync both the Git and the local Git repo and the remote repo. First thing first, I'll go to GitHub. If you don't already have the account, you can create an account and create a repo. A new repo. I'll just call it homepage maybe. Yeah. And then you can choose to put the description. It's optional. I'll just say HTML and CSS static page. Yeah. You don't have to put the description, and you can either make it public or private, or choose the private. And then you can choose to initialize your repo with either the README file or getting or a license. But I won't do that right now since it's a basic project. And then you create your repo. From here, you see that this is an empty Git repo where our files would be located online. You will just save your files here. What I'll do is copy the URL for this repo and head to the terminal. So how you add your remote repo to your local folder or to your local repo, how you sync them is by using this command git remote add, and then the name of the remote repo that you want that you are syncing with. You can give it any name, but usually the name we know is origin, which I'm gonna use. this can be any name you want, and then followed by the URL of your repo, your online repo. I've added the repo to check if we have online repos. We use the command git remote with the v flag. And then here we only have one remote repo where you're able to fetch from that repo, and you're also able to push from it. So fetching, you getting the information, you're getting files of the changes from GitHub to your local repo, and then you can also push your local changes to GitHub. And as you notice here, this is the name that I gave this repo. You can give it any name you want, but this is it's widely used by many developers. Cool. And from here, I want to make my first push. Like you can push at any point in time. So I'll just push it to GitHub right now by using the command git push, and then followed by the name of the remote repo you want to push into, which is origin, and the branch that you want to push to to GitHub, which is master. So when you're using Git for the first time, and then you want to push for the first time, it will ask you for your username and for your password. You use the same information you made when you signed up, when you created your account. And this is pushing. It shouldn't take this long. I don't know what's going on, but yeah. If it's not pushing, if you get an error after pushing, or you're struggling to push your files online, what you want to do, or maybe if you want to push it and don't want to fix anything, you can use the command git push origin master and the force flag. This is not recommended, but you can, maybe if you're desperate, you can do this. Yeah. And then from here, I want to go to my GitHub account and my repo. Initially, there were no changes. It was empty. And if I refresh this, I'll see the files that I have on my local repo, which is the assets and the two. Cool. From here, I want to start working on the project. Like I said, I already have the code. I want to start this from scratch. I'll just copy the code that I have. Okay, before that, when you're working with Git, you don't want to interfere with the master or the main branch. What you want to do is, when you want to add a new feature, you can work on a different branch, which is not the master, and then join them together later. What I'll do now is create a new branch where I'll work on my index file or index content, my HTML index. And how to create a branch, use the git branch, and the name of the branch. You can give it any name, but by convention, I'm used to saying, if I want to create a new feature, I can just say feature, and then the name of the feature. In this case, is the skeleton. I'll just call it the skeleton of the HTML or the static page. So what this does is that it creates a new branch in your local repo, only on your local repo. And to check if you created a new branch, you can use the command branch, or check all branches that are there. You can use git branch with an A flag. A means all the branches. So I have the feature skeleton, which is the branch I just created. I also have the master branch, the local master branch, which is the branch I'm on right now. And we also have the master branch on GitHub, it's the remote branch. So I want to start working on my HTML file. I'll go to the skeleton branch by using the command git checkout and the name of the branch. Yeah. So checkout goes from your master or the head you are currently on to whatever you're specifying here, which is the branch skeleton. And you might have noticed that it changed from master to this branch. And now you can start working on the HTML file. This is the content that I have right now. You can save it, and maybe check it on the browser and see how it looks. Oh, nice. So yeah, this is the first version of my page, my project. I don't like it, but I'll improve it later. But I like the skeleton. What I'll do is that I'll add the changes to Git. I'm satisfied with these changes, so I'll add them. I'll put them in the staging area using Git, add everything, or you can just specify the name of the file. And then I'll also commit the message. I'll just say edit HTML content. Cool. From now, since I'm done with the skeleton, and I'm sure that I wanna. Okay, I see an error. I think I have an error, so which doesn't matter. We'll fix that later. I'm done with this feature, and I want to join you with the main project or the master branch. What I'll do is after committing, I'll go back to the master branch by using the command git checkout and the name of the branch that I want to go into, which is the master branch. So if you go back or if you check out to a different branch without saving changes, they'll be lost. So you have to make sure you commit your changes before you check out to any other branch. And you might have noticed that this thing right here, you might have noticed that there's no content on the master branch, which the changes that we just made are not present on the master branch. What I want to do is I'll use a command called git merge and the name of the branch that I want to merge, which is feature skeleton. So here you must make sure that you are under the branch that you want to merge into. For example, here I want to merge into the master branch. I want to merge the skeleton branch into the master branch, and I'm currently on the master branch. Use this command git merge and the name of the branch that you want to merge. And yeah, we have the content on our master branch now. So we've joined both of the changes on two different branches. And then from here we can, in other cases, you can find that there might be a conflict, meaning that Git can't merge your changes because maybe two developers were working on the same for example, same CSS selector, and you both editing the same, and then you want to merge it. There'll be a conflict which Git can't fix, and you have to fix it manually. I think I'll make an example later on. Yeah. Cool. And from this point, I want to work on my CSS, my styles. And since it's a new feature, I want to branch out from the master branch and go into make a new branch that I want to work on, since we don't want to mess with the master branch, the content of the master branch. So how I'll do this, I'll create a new branch and then go into it. So there's a shortcut. If you don't want to create the branch on command and then go into the branch using another command line, you can just use one command called checkout and the flag B, then the name of the branch that you want to create. I'll call this one feature styles. Yeah, styles or design. You can call this whatever you want. So what this does is it creates a new branch and then it goes into it since we're using checkout. So the B flag creates a new branch and checkout goes into that branch. So now I'm in the styles branch and I want to add my CSS or my styles. I already have them. I'll just copy and paste. Cool. Save. Okay, from this I can stage my files, stage them by using this command, git add, and then commit the changes. With the description, I'll just say edit styles. Yeah. And then for Git, I think, you should, when you're working with Git, you should be committing as many times as you can. It doesn't really matter, but yeah, I think it's better committing as many times as you can. So from here, I've committed, and I don't want to merge this branch locally, since maybe, let's say I'm not the project manager and you are assigned to work on the styles feature and you're done working with it. So you have to give feedback. You have to get feedback from your project manager, how your project manager will see these changes is through GitHub. And before that, you have to like push those changes to the remote branch. So we'll use the command git push, and then we'll set a new we'll set a new remote branch using the set upstream flag, and then the name of the remote repo, then the name of the branch. So this is just the long version of the flag. If you don't want to type this long thing, you can just use the U flag, which is fine. So this is gonna push all the content in the styles feature branch, the branch into GitHub. But since we used the U flag, it's also going to create a new branch online. If you go to our GitHub, you can see that this thing which says you've had a recent, it says you have recently pushed a branch into your remote repo into GitHub, and you notice that there's nothing here. Those changes are not on the main branch. What your project manager will do is they'll go to GitHub and view the changes that you made. But before that, you have to make a pull request so that whoever is going to review your work can approve them, and stuff like that. So what I want to do is you can give your commit or your pull request a heading. I'll just leave it like this. You can also leave a comment on what you want the reviewer to check. I'll just say maybe check out my CSS styles. It's just a comment that you want to leave for whoever is reviewing your pull request. Cool. From here, you can go back here, and then your project manager or whoever is reviewing your changes can go to the pull request tab. As you can see, there's one pull request. You can go here and you will notice that there's an open pull request, and then you can go to that, can click into it and then check what changes were made. As you can see, there are 2 commits and there are 2 files that were changed. Cool. You can also leave a comment if you want down here. As a person who's reviewing this, you can say maybe I like the new changes. Nice. And then you can add the comment. This is gonna appear here. It's gonna appear here. Yeah. And then if there is no if there are no conflicts and you are happy with the new feature, you can merge it into the master branch. Join it with the master branch. You can just click that. You can add a message or a commit message. Yeah, a commit message here, and I'll just leave it like this, and then you merge it. Cool. If we head back to our code, after merging, you'll notice that now we have new changes on the master branch. This was not there. The commit was in there before. Yeah, that's how you make a pull request. So what I did is I started here working on the new feature, on the new branch. I branched out from the master, created a new branch on the local repo, and then worked on that, work on the changes, work on the features. And then from there, I put them in the staging area, and then I committed the work. From there, you can push that branch, the specific branch, onto GitHub, where you can make a pull request. You can go there and make a pull request here, and where someone else can review the changes and then approve them, then match them. After that, you will see that all your changes will be on the same branch as the master branch. Cool. And also, if you want to check all the branches that are online, you can click there, and I have only 2 branches, the master and the feature styles branch, which I just uploaded. Cool. And then from this stage, I can check out to the master branch, and you will see that there are no changes. We don't have the styles. And how we get that is we can pull the changes from the remote repo from GitHub. We can pull them using the command pull, and then the name of the repo, the remote repo, and the name of the branch you want to pull from. So in this case, I want to pull from the master branch. Cool. So this is going to upload all the information the changes that were made online into the local Git repo. And if you go to the CSS file, we see that there are changes now. Cool. And what I want to do now is I want to work on maybe let's say you want to undo some changes. You made a mistake. Actually, let me make a mistake, purposeful mistake. Let's say you want to make new styles. Let's say body, yeah. Add a new style and whatever it is, yeah, and then you save. You save that work. You add it to the staging area. Then you commit the changes. Added an error. So we've added the changes to Git, and I'll just review all the commits that I made. How to do that? You use the command git log. Okay, git log. So what this does, it will show you the full details of your previous commits. So what it shows you the ID, the long version of the ID, and the author, and the date and time, and then the description message. If you don't want to show all this information, you can just use git log and a flag called one line. It's going to summarize your comments. You might have noticed that this ID is now shortened, and we also don't have the author and the dates, we just have the message. So from this, I don't like the error. This thing is messing up with my static page, and I want to remove it. I don't like it. There are 3 ways of undoing changes, from safest to riskiest. The first way to undo a commit or maybe make some changes is you can use the command git checkout and the name of the ID, specify the ID of the commit. What I want to do is that I want to go to this time where I added the styles, or maybe let me just go to this one. Yeah, let me go to this where I added the HTML content. So what this command does is that it goes back in time to this commit or to this time where you made these changes after committing, just to check. As you can see, there's no content on the CSS file, and also there's no, okay, wait, there's after. Yeah, there's no content here and there. From this point, you can decide to make some changes or add some new content from this point, or you can just choose to go back to your master branch or to whatever branch you were in. So how you go back is by using the git commit, git checkout, and then the name of the branch, which is master. Cool. But now, if you didn't want to just check, let's say you wanted to edit it or add some content on that point in time, let me just go back to that commit. Let's say I want to add some styles. I'll just add some random styles, color white. Cool, that's fine. And then from here, this thing is, it's in the modified stage. You made some changes. What we'll do now is add them to the staging area by using this command and commit with the message changed. Some content. And from this stage, since you've modified your this commit or this point, this version of your project, and you want to go back to the checkout, go back to the master branch or whatever branch you were working on, you can use the git checkout master. And then from here, since you did some changes, Git will require you to maybe merge or create a separate branch that will keep the changes that you made, and then you can choose to merge them later. What I'll do is that I'll create a branch with the changes that I just made from that commit by using the command they gave us here. So you'll say git branch. Okay, you're creating a branch, a new branch. I'll just call it random branch, whatever. And then specify the ID of the commit that you want the content. Yeah, so when I add the content of that commit, of that specific commit. So I'll just add this ID here. What this does is that it takes the changes that you made on this head, and then it puts them in a separate branch called random. Like that. And then from there, you can check if we have the branch. Random is already there. And if you want to keep the changes, you can choose to merge this branch with the master branch locally or remotely. I'll just do it here, git merge random. So you can see that there's a conflict. There's a conflict because I edited the same CSS selector, I think. And also there's an error. Yeah, I have to remove that error, but yeah. So what happens now is that you have to fix the conflict. There's a conflict within the body selector. And yeah, different styles. I have different styles. Where's the other one? Where's the other one? Cool. Cool. So what I want to do, you can choose the Git can't fix your conflicts, so you have to do that manually. I'll just remove this thing. I'll just delete this because I don't need that. I'll just delete that. You can fix it however you want. But yeah, cool. And then you save. I'll also remove this thing, by the way. Maybe, yeah. I'll also remove the error. Maybe not. Okay, yeah, maybe not. From this, you can just add everything, git commit merged. Cool. Yeah, that was fixing a conflict. So if you have a conflict when you're trying to merge, you have to fix that manually. Git can't do that. Can't decide for you which changes you get to keep. You have to decide that yourself. So what happens now once you remove the error, this thing, the commit that's causing this error, I want to go back in time where I made this change and then remove it. I'll just check the IDs, the commit IDs. And I've made the error, I've made the commit here where I added the error and I want to remove it. How we do that is using the command git revert and then the name of the ID. What git revert does is it goes back in time to that specific commit. It goes to the specific commit that you made, which is the added error. And then when you press this, it's going to remove the changes. It's going to remove the changes and then make a new commit with a different description and a different ID. So that's what I'll be doing. As you notice that there's no, the changes that I made at that time that disappeared. And then we can save this. We can give your commit a new description. I'll just leave it like this. Yeah, WQ, cool. And then now we have the new changes without the error, and it has given us a new commit. If you want to go check the new commit, it has a new ID and a new description. But the thing is, when you're using revert, your changes, the error that I added, I can still go back and check it out. I haven't removed it. It's still here. The commit is still present. This is the safe method if you want to remove some changes and or remove a specific feature. Maybe your project manager tells you that they don't like the feature that you did maybe 2 months ago. You just remove it, but keep the changes that you've worked on from that time or before that. And now let's say you wanna remove the changes, like remove changes from a point in time. Okay, for example, let me make an example. For example, let's say I was here. Let's say I don't like anything beyond this point, beyond the added HTML content point, and I want to remove everything after that. What I'll do is that I'll use this command git reset and to specify the ID. I'll just take this one. So what this does is that it resets your changes from the point from this stage. So after I've committed here, So after this commit, the changes that you made won't be saved to Git anymore. They'll be either unstaged or removed completely. So you can do this in two ways. If you want to remove the changes but still want to keep the edits or the contents of your changes, you can just use it like this, the plain command like this, which is git reset, and then the name of the ID or the ID of the commit. Boom. So what happened here is that you see that this is now unstaged, and this was edited after it was committed after this point. But now since we resetted, anything beyond this point will be removed from Git, and we won't have these commits anymore. And yeah, I just want to check if we have them. Cool, yeah. You notice that there's nothing beyond this point. Everything after this ID, every commit you made after this point will be lost, but your content will still be here. My CSS content is still here. But if you don't want the commits, if you don't want the changes or the content to remain behind, let's say you don't like the feature at all, or you don't like the things that you did from that point, what you do is use the command git reset, or maybe before that, let me just add the changes. Let me just add them and then commit them. Okay, set that. Cool, and then I'll just do this git log online. Wow, okay, cool. I'll just edit this thing. So let's say I don't want anything beyond the stage. Anything after this commit, I don't want it, and I also don't want the content. I won't be needing it later on. So the command that you use is git reset, and then you specify the name of the ID, and then you use the flag hard. So what this does, it removes the commits from your Git, and it also removes the content edits from the local, from everywhere. So the hard flag, it also removes the content. We don't have anything after that. If I may check, you only have 2 commits. Yeah, so that 3 ways. The first way was checkout. The checkout allows you to go back in time and just check the work you did. The work you did, and then you can choose to maybe add some content from there and add some new features. Yeah, so checkout is the safest method you can use to undo stuff. And then the riskiest way to undo stuff is this one, the reset. If once you reset your commits, you can't get them back. So you have to be sure that you want to remove the content. And then the least riskiest or the least safest way is revert. Git revert. Revert, what revert does, it goes to a specific commit and it removes that commit from Git, or it removes the changes from Git, but it keeps that specific commit. Let me start over. What Git revert does, it goes to a specific commit to specify the ID, and it removes those changes and then adds a new commit with the removed changes. I hope that makes sense. So cool. And from this point, I want to just push all my work to GitHub. Since I'm done with the project, I just want to add everything to GitHub using git push origin master. Right, so this will push all your stuff to GitHub.
Hi, Sabelo. So there's a question in the chat. I don't know how long has it been there. Yeah, it's been there a long time. I don't know if you want to answer it now or maybe after you're done, you can decide.
Okay, let me fix this error first. Cool. So since this thing gives me an error, I was not able to push. You can choose to fix the error manually or like see what happened. But if you are in a rush, you can just use git push origin master and then a force flag to push it forcefully, which is not recommended, but you can do it if you want to. It's your choice. And it's pushing. If we go to our GitHub now, we can refresh and yeah, as you can see, there is no, like we went back to the previous commits where we added some files without any content, without the CSS content. Yeah. And then one last thing I want to do before I answer the question, I just want to add the README file, just for convenience sake. I want to add the README file, can commit that. And yeah, I have the README file now. So I want to add the README file locally. I want to add that locally. I'll just pull the content from GitHub to the remote to the local repo using git pull origin master. And we have the README file here. Yeah. The question says, let me see. Does adding new features automatically update the version of your project, or how does version numbers work? Okay, so adding new features, it just adds a new commit. It just adds a new version of your project. Yeah, it adds a new version, but it keeps the old ones. Where you can go back and check them using the IDs and stuff. So versions have the specific IDs, the specific commit IDs, which you can use to go back in time and work from there, or yeah. How does it work? I'm not sure if I understand your stuff, but yeah, adding new features, it does update your version of your project. And yeah, I'm not sure if I answered your question properly. Cool.
Yeah, I don't think it's here left, but yeah, I think you can continue.
Cool, yeah. So yeah, that was the last thing. The most important thing I wanted to cover was the checkout, the undoing stuff, the checkouts, the revert, and the reset. Because on the last hackathon, one of our candidates lost their work because they made a mistake. Probably they used the reset. But yeah, you use either of the three with precaution. The checkout is the safest, and the riskiest is the reset. Thank you.
Cool, everyone. Please, I'm just gonna post a link in here for you to give us some feedback. Let us know how the event for you. We really value your feedback. If you have any questions, please also you can unmute yourself. Sabs, I have a question for you actually. Can you like just like take me back to when you were doing the PR request, like from like pushing to your remote? I don't know how you did that, but I mean, I think I missed it somehow. Like before, like you went to your GitHub, like to do like to accept the pull request. How did you get that again?
Pushing what a branch, a separate branch to.
Yeah,
okay.
yeah.
Okay, sure. Let me do this. It's fine. It's fine. I'll just do this. So what you do is let me just do this. Yeah, git branch. Let me create a new branch, which I'll just push branch. and then say make changes and stuff like that. Or I don't have to make anything. So how you push a separate branch is using this command, git push, and then you set, if it doesn't exist on GitHub, you can use this flag, the U flag, or you can write it in full by saying set upstream, and then the name of the repo, the remote repo, and the branch that you want to push, the name of the branch that you want to push, which is branch. I called it branch, yeah. Is this what you were asking?
Sure. I think it is. Yeah, I just want to see on the other side as well, on GitHub.
Okay, so it's done pushing, and if we head to, okay, I only shared, let me do this. Cool, yeah, if you go to GitHub and refresh, we can see that we have the branch now. We have the branch present. It wasn't present before that, but I pushed it from, yeah. And then since I didn't add any changes to that branch, there's no, I don't need to make any pull request. I just created a branch and then pushed it to GitHub. But if there was but if there was like changes, you make a pull request, then yeah.
Cool, great. Thank you everyone for coming. I think this is the end of our event.